Okay, so as I mentioned in class today, the product rule is a shortcut to help you get the derivative without doing the formula when you're not given an equation in standard form. So what I mean by that is if you've got an equation that's all entirely connected by addition and subtraction, then the shortcut is we just take our exponent, multiply by the coefficient, and drop a degree. So it would be 6x squared plus 6x plus, again, the derivative of a constant is nothing. So you can just look at it and get your derivative, and again, the f prime notation is the derivative. So that's a straightforward kind of concept that we've been working on a couple days, but if we take a problem that looks like this is no longer in standard form, meaning there's an operation that connects this to this, right? There's a multiplication that goes on. So if you remember from what we did today, the shortcut for finding the derivative when there's a multiplication problem in the problem is we take the derivative of one of the objects, leave the other one alone. Then do the same thing in the other order, meaning if you took the derivative of the first thing the first time, then you would take the derivative of this thing next time. So basically I'm going to have four things. So I'm going to write parentheses to represent my four things. It's always a plus sign between those four things. So I'm going to separate my parentheses. So I look at these two things. I just pick one of the things to keep the same, and I pick one of the things to take the derivative of. So this looks terrible, so I'm going to leave this thing alone. So if I leave this thing alone, that means I have to take the derivative of this. So that doesn't seem terrible. The derivative of that is 9x squared. Oops, that's not right. Take the coefficient and multiply it by the exponent. So if I do that, 3 times 9 is 27. Drop a degree. Bring this down. 2 times -2 is -4. Drop a degree, meaning subtract 1. And so there I have my second part. Pick one of the things. Leave one thing alone. Take the derivative using the shortcut of the other thing. For these, I'm going to do the exact opposite. So for this one, I took the derivative of blue and I left the pink one alone. So at this time, I'm going to leave the blue alone. And I'm going to take the derivative of this. So if you remember, the derivative of square root of x is a lot easier if you have it written as an exponent. So root x is the same thing as a half. So the derivative of this, multiply this times this, which is a half, x to the first power, oops, sorry, this is x to the 1 degree less than this. 1/2 minus 1 is the same thing as 1/2 minus 2 over 2, which is -1/2. And so I'll write it like this. Then I'll fix that negative exponent by bringing it downstairs and making it positive. Ta-da! See? Piece of cake. And now all I have to do is multiply these two things together. To be honest, I really don't want to do that. There's a lot of mess going on here. So if that's as far as we can get, I'm okay with that. But if you really want to be technical, I'm going to rewrite this as x and a half. Multiply this. To be honest, if I'd picked even easier numbers, it would have been much easier. But since you asked for some tricky problems, I'm going to give it to you. So multiply this times this, 27 x to the, when you multiply exponents, you add, when you multiply same bases, the exponents get added. So 2 plus a half is the same thing as 3/2 minus 4x to the, when you multiply bases, oops, that should be 5/2. Because 2 plus a half is 2.5. 2.5 is the same thing as 5/2. 1/2 plus 1 is 3/2. So there we go. So if I distribute this, this times this is this, this times this is this. And again, I'm not going to, no, like you don't have to do that on the test. If all you did was get this part here, I'm okay with that. My concern is that you understand that when you do this problem, you can't just take the shortcut right away because of the multiplication that's occurring here. And so if you do multiplication, pick one of the objects, keep one the same, take the derivative of the other, and then switch it for the next set of parentheses. So if you left this one alone, then on the second time you take the derivative, what you left alone here is going to be what you derive in the other one, and vice versa. All right, and then these will turn out to be a little bit nicer, and then you can distribute nicely. If it's not distributing nicely, then you can just leave it like this. The goal isn't to get you to distribute, it's to deal with how to figure out what the derivatives are. So if you could follow along with that, you're all set for Friday.